You know, what you're looking at is the good part of the board. I cut off the ends that like burned in common fire. So we got a long way to go. We overcooked this, and we're going to try to do it again. When we made this last week, this process took about an hour. So we think that we can do it now, put it in the oven. We're going to run that machine just on wood chips today. And normally that process would happen with excess biochar process heat, but for now we're going to do it just on wood chips alone. And keep the temp down. We might run it a little bit longer than an hour, kind of ramp it up slower. We're just going to see if we can make a better board. And hopefully before you guys leave today, we'll be able to open it up and see how we did. So I was just going to kind of walk you through our little experimental process here. We've only had this equipment set up for, I don't know, not even 2 weeks yet. So let's see. I got this mold that we made. And I think the guy's name, if you Google precious plastics and you get into the forums, I don't want to get his name wrong now, but it's something Mark. It's like Mark B something. I don't know. I'll reference it later. But he made a really nice compression molding machine that has a couple of different qualities. It's got a big bed, and then it has this little edge on it. That edge becomes like a knife edge. We can load this thing up with plastic, and then we'll have like this top part, kind of a plunger deal, that as it heats up, that'll weight it down. And then when we're ready, we'll pull it out of the oven and we'll press it. And then all the excess plastic, you know, it'll fill up the bed here. All the excess plastic will roll over that edge and go out. And then once you press it hard enough, you can cut along this edge. So ideally, we'll have a nice like square edge. So the edges of that board indicate how that should look. I thought that was pretty clever. But he uses automotive jacks, and that's what we're going to use to give us that pressure. You know, those are readily available, and they're cheap. You know, I think we paid $30 for $40 for each one of those jacks. So that's a pretty cheap 40-ton press. And all of that steel came from the junkyard. I'll quiz one of you guys on if you recognize. You probably won't recognize that steel because we painted it. So I'll just go ahead and say it. It's all made from, when you're driving out of here and you get on 26 and you see the guardrail that's like this high, right? Okay, that's all made out of that galvanized I-beam. Now that much of it's out of the ground, but that much of it's underground. So those boards are actually, or you know, those beams are 6 feet long. And anyway, we found a big stack of them at the junkyard. So we got it for, I don't know, we bought that steel for $20 maybe. This is different. We actually paid for this. Anyway, point is, it's a very low capital investment for this kind of thing. Where's our silicone spray? Have you got it? Okay, there it is. All right, so we've been using this stuff. Has a little bit of Teflon in it as a release agent so that the plastic doesn't stick to the mold. Now, I'm not ready yet because we're experimenting with so many other things, but eventually we'll experiment with not using this, but I don't want to do that now. So we'll do a real light coating on all surfaces that are going to see plastic. And then got my little riser here too. Y'all can come up close if you want, or if you don't want to smell this, that's fine. All right. Let's see. We learned in some of our early experiments that, you know, when dealing with the flakes, and especially with dealing with these bags, that you just, you know, you can't compress them on your own at all prior to going into the oven. So you've got to have, you know, dealing with our flakes, it's by volume, it's, you know, if you've got 12 inches of flakes, it's going to compress down to 4 inches. You know, those were some of our early tests were how big does our mold have to be? How much compression do we need to accommodate? It's the same with the bags. You know, we've got to raise it up 4 inches if we want to make something that's only going to become a 3/4 inch board. So one thing I like to do is use something that I know is polypropylene and try to mix in like a cool design, you know. These are polypropylene flakes that I made some time ago. I don't remember when. So what I like to do is sprinkle some polypropylene flakes on the bottom here.
Daniel, how did you make the flakes?
What's that?
How did you make the flakes?
With that machine?
Okay.
Yeah. All right, so that stuff will kind of disperse as a colorant, and ideally, again, this is all like totally experimental. We should be able to get kind of a nice rainbow effect of some degree. Eli, show them that board that we just pressed out yesterday. Okay, now I tried to do it yesterday with that board, and that's the effect. I think we did not get that board hot enough, and we did not fill the chamber up enough. But you can see the effect we're going for there. Yeah. Yeah, there on the back. It's kind of dirty. We're definitely dealing with some dirty steel here, too. That's not helping us at all. When we get this to work, I've seen that some people actually do like a little stainless steel plate lining or something to give it a better finish than what we're dealing with. But so, again, these are the used bags that if I can't pick them up with the forklift anymore, then I can assume that they're UV degraded beyond reasonable use. And I'm just going to start packing this thing in here. It's going to take a while, so you can either watch me or walk around if you want. It is just kind of a game to get all this to fit. I think this has to be cut out though. Okay, you guys just start getting it in there. See these little flakes that are coming off? That's kind of that's going to happen with the UV degraded plastic. I guess we all know what that looks like.
So this is like the big, what is it, like 220 pound, whatever, like soil bags, mulch bags? Like the big ones with like the big totes?
You can probably see them out there. They're bigger than the ones that you buy
At the store?
at Lowe's or whatever. Yeah. So those are
okay.
those are three. Well, you can't see them. Well, yeah,
Well,
maybe
yeah, stacked
through the
up,
yeah. Yeah, it's stacked up, but then just right behind them, those are still full of crushed biochar. That behind the conveyor over there.
Oh, wow.
So they're big 3-yard bags.
Yeah.
Um,
Right
Yeah, so we got a lot of that stuff. Some of those have been sitting. We kind of dropped the ball on the rotating the stock, so some of those have been sitting out there for almost like a year and a half.
on. Oh, wow, yeah.
It hit
That lasts a while.
pretty aggressive UV light degradation there.
Now those are the handles, with the blue.
Yeah.
You don't put them in there, or they got fiber in them? Like,
No, they'll go in there too.
Okay.
Yeah. Labor intensive, huh? Right? So another thing I wanted to do, and you guys can decide if you want to do this now or later, is a little how to identify plastics demo. And it might be appropriate to kind of do this at the same time because we've got a lot of stuff we want to try to show. You guys want to do that, and they can kind of finish filling that? I think this is going to take a while.
Yeah.
You think that's enough? I don't know if that's enough. It should be all that. It should be 2 bags.
Well, that was more than 2 bags, I think.
Was it? Okay.
I think they
Let's give it a shot. Let's do it. Okay, so that's going to go in the oven.
How do you fit in the oven?
Big oven. It's not the
Good question. That's funny. Do you want to haul it out?
They have a special oven.
Let's see.
Sounds good.
You want to get the forklift on it? Yeah, I think 320 is its like melting point. So we probably need to try to stay under 320.
You wanna move it so we get the forklift?
Oh yeah. This is the press, by the way. We're going to see this later, but this is what we were talking about. These are the beams that are mostly underground, you know, just kind of neat. So welded this up pretty inexpensively. We actually had to upgrade this beam. We originally had another one of these that we were pressing against and bowed up pretty quick. So we did upgrade to a new beam. We got this, I don't know, 4 years ago, I bet, and it's been sitting under the shed waiting for a use. So glad to have actually used it now. These jacks, called bottle jacks, they're extremely inexpensive for what they're capable of. Oh, oops. Good to go? Yeah, light it up.
This is a hardwood chip gasifier. We're going to send heat under this and heat it up to 320 degrees, I think is our target temperature. And hold it there for a little while and then take it out and press it. And hopefully it's good board.
So another thing I wanted to do is a little how to identify plastics demo. Got a bunch of different unknown plastics. Some of these I already know what they are. Some of them are labeled, but certainly if you want to try to do this and you're bringing in like all kinds of different plastics, then you do need to know what they are before you try to start going on to form them. And there's a lot of there's physical ways that you could test it. You can kind of see like, what does it look like? Does it bend easy? Does it scratch? You know, is it hard or is it soft or is it flexible or rigid? You know, so there's kind of physical tests, and then once you kind of get to know the plastics, you'll mostly be able to do it through there. But there's some that are kind of a little bit harder to tell the difference. You know, a lot of times it's hard to tell the difference between like polypropylene and HDPE because they just at a point they kind of have the same feel, and additives kind of throw everything out of whack. The same, I noticed the same with polystyrene and peat, kind of had the same feel. And polystyrene and peat, you absolutely cannot mix those if you're trying to make anything of any kind of structural value. Now, I'll kind of step back and say that I did come across guys that are making, they're doing something real similar to what we're doing out there, where they're just mixing all plastics together and making big bricks out of them. And they're just kind of like tying up bricks, and they're like lining the street with bricks. Now, they're also making them in like a residential oven that's been retrofitted into a compression machine. So you have to think like, how many bricks are they actually making, you know? But nonetheless, though, they can do it, and it's pretty neat. Another group that I saw that was mixing all plastics together is they're making really beautiful tiles. And they're about maybe half an inch thick, I think, and they have little beveled edges, and they look very professional. But they don't have to bend or bow or crack. You don't have to do anything with them except just like put them on the wall. You know, they're decorative tiles. So if you want to maintain some structural integrity, kind of know what you're working with, then you got to be able to sort it out. A couple of different ways. There's a combination of different ways to test, and this is kind of the high school like science lab method here, using water. Okay, if we float, then we know, we're talking about the 6 main commodity plastics, the ones that we already talked about. If it floats, then we know that it's HDPE, LDPE, or polypropylene. Those are kind of all, a blanket term for those are called olefins. They all kind of feel and act the same. So if it floats, then it's an olefin. If it sinks, then it might be PVC, might be polystyrene, it might be peat. It might be anything else. There's a different process for if it sinks, but if it floats in water, see how this guy's a little floating here. So we know that bottle cap is HD, LD, or PP at this point. All these bottle caps. Oh. Okay, we got one that sank. It took a long time to sink, but it did. How about this guy? What do y'all think this is? Let's find out. Well, it's not floating. I think that's a good start here. Okay, so next step is, does it float in alcohol? Now this is like, actually, and I'm going to tell you right now that I didn't get this right. It's, you really got to nail it in terms of density. You're supposed to be able to identify the difference between LD and HDPE if it floats on alcohol or if it doesn't. You got to nail it though. See how this guy took a while to sink? Or it's kind of like in the middle? You know, I'm going to guess that that's HD and that these other ones may be LD. But they're all floating. It's incredibly tight tolerance in between the two. Now you can get online, and one of those references, I think on the last slide, I gave you a link to Appropriapedia, which is like a Wikipedia for appropriate technologies. They have a really good guide for identifying plastics, and they'll tell you exactly how to mix your alcohol and water to get the density right. Okay.
What kind of alcohol is that?
That's isopropyl. Yeah. Okay, last one is, does it float on oil? I think that these are all going to float. Okay, that guy sinks. They're all going to sink. I didn't want to waste a bunch of oil, so. I got these chips over here that I made. Before I paid too much attention, and I just kind of assumed that these were all polypropylene. So what I want to do with this is actually test, using the oil test to know if these are polypropylene. And if they sink, then I know they're not. So let's see if I've got enough oil in here to actually tell. You guys see that? The black ones are sinking. Okay. So we definitely kind of made an assumption that we were dealing with polypropylene when we were using LD or HDPE plastic. Okay, so that's pretty neat. I'm glad we were able to see something. Looks like whatever that white fleck in there is also going to be LD. Okay, so what about these other ones? This little cup, this little blue piece of food packaging, and this pipe. I think we all know what this pipe is. You know what? Let me go wipe my hands real quick. So we're going to do the copper wire test. This one's pretty fun. We're going to test to see if this plastic has chlorine in it or not. And what we can do is heat up a piece of copper wire. We all know this is PVC pipe. We know it has chlorine in it. We also know we don't really want to breathe this, so we're just going to do a real small sample. All right, I'm going to get my little wire nice and hot. All right, see, I got a little piece of PVC on there. See that green flame? That's the chlorine burning off. You know what's even neater is that it's a little green flame. Now, if I was to do that with this guy, this is called CPVC. It's like a PVC that's been designated safe for hot water use. It is over 50% chlorine. So it's actually going to be quite a bit greener. It's pretty neat.
And that one's supposed to be safer?
I know, right? That's the one that didn't make sense to me either. I think they're pretty much phasing this stuff out. All right, well, I'm not going to do that on these because I know they're not PVC. But you guys get the point. It's kind of neat to see a little green flame like that. All right, so the next one is the acetone test. Now, we know that peat is resistant to solvents. And we know that polystyrene is not. So this is actually kind of a way that some people have done little experimental ways of recycling, repurposing styrofoams, is to actually dissolve it in acetone. And you can kind of get like a little goo out of it that
You can put that into a mold.
Yeah, yeah,
I
yeah.
think I've seen where they make like blocks, like building like houses, or I don't know if it's for houses or not, but like building blocks.
Yeah. Yeah, I don't know. I mean, I don't know if it's really like a practical way to use it. You can still heat it up, you know. You don't have to dissolve it in a solvent. But anybody want to feel this? Kind of feel what's going on here?
Can you stick your finger in there?
No, don't stick your finger in there. It's acetone. It's not something you really want to be messing with.
It does feel soft.
You see, it's definitely starting to get soft. Now, if we let that sit, you'll be able to come over here and stir it, and it'll just turn into like a little gumball. You know? Oh, what am I doing? Here we go. Yeah, I don't know if we got a piece of styrofoam around here or not. Okay, the last one is the heat test, and it's supposed to be able to differentiate between polystyrene and peat, number one. Now, these feel very much the same, and they're both used for food packaging, and these are probably the hardest, I think, to tell the difference between. Now, polystyrene will deform in water. Peat will kind of be a little bit more resilient. Okay, I don't think I got that water hot enough to do that, but we can try. Again, these instructions are on a Propopedia. That's the best set of instructions that I found for this. They'll also go into, and we're going to be limited from time, but they'll go into a very detailed description of what it looks like when you light it with a lighter. You know, we can actually, let's do that and see if we can tell a difference right here in this room. Oh yeah, quite a bit there. I think I said that wrong earlier. Peat is actually deformed quite a bit just by dipping that in hot water. Okay? And it's not even that hot. This still looks like a cup. Okay? It's pretty neat. So I don't, you guys want to do the flame test or you want to not get smoked out? Okay. Fire. I don't know what we're looking for. I didn't memorize the flame test, I'll admit. All right, a couple of things we're seeing. It's kind of like, it's a self-sustaining fire, okay? It's keeping itself lit. It's kind of a little sparky, and it's not dripping, okay? Those are all things that descriptors, what you're looking for. Is it gonna drip? It is making little char balls. It's definitely got some sooty smoke, but it didn't drip. This guy, I don't know. Let's see what happens. That's a sooty flame. Yikes. That's the one. You definitely don't want to be breathing that either. Yeah, I'm actually going to say I don't think that was a sooty flame compared to that. That's a sooty flame. And that smells like burning styrofoam. So let's get that out of here. You guys want to keep going? You want to burn some other stuff?
Okay.
All right, we already know that this is a polyolefin. It's either HD or LD or PP. I think it was floating or it sank in the oil, so we know it's either HD or LD. Kind of a, you know, it's going to drip. It's about to drip. Yep. It's drippy. It's actually relatively clean. I mean, that's not sooty at all. And it's not really charring or anything, but it is a self-sustaining flame. Again, you can look on that. You guys smell that? That's kind of like, it smells like paraffin wax. That's definitely the trademark HDPE smell. Polypropylene is supposed to have like maybe a little sweeter smell to it when it burns. Again, what I've printed out here doesn't give all that detail, but online and on the Living Web Farms website already, I've already uploaded it, is a much more detailed identification guide. Any questions? You guys want to? You ready to go?